Okay, so now we're going to do example problems on page 11. And I understand we skipped a couple problems in between, but we will do those tomorrow. We skipped a couple notes pages, but we will get to those tomorrow. And so let's see, let's do question 1. What is the probability of flipping a heads or a tails? Could they be considered mutually exclusive? Why or why not? So there's a lot of things to consider here. And the first thing is to consider where to start. The very first thing you want to do is notice that this is an or problem. And you want to find the probability of flipping heads or tails. You need to now ask yourself, can these two things happen at the same time? When I flip a coin one time, is it possible that it shows both heads and tails? And you should be saying no. They cannot happen at the same time. So are they considered mutually exclusive? Well, my definition of mutually exclusive says these two things cannot happen at the same time. So yes, these are mutually exclusive. And I'm going to put ME for that. And it says explain why. Well, because they can't happen at the same time. At the same time. Alrighty, but now I need to actually find the probability. So I decided that these two things cannot happen at the same time. So they're mutually exclusive. So I go use my mutually exclusive formula. Probability of A or B is equal to the probability of A plus the probability of B. So the probability of heads or tails, H for heads, T for tails, is equal to the probability of heads plus the probability of tails. I just add those probabilities together. I don't need to subtract anything because we decided that they can't happen at the same time. So the probability that I get heads, well, there's heads is one option out of the two available. And the probability that I get tails is also 1 out of 2. And so 1/2 plus 1/2 is I can add the tops and get 2/2, which is equal to 1. And that should make sense. When I am flipping a coin, the probability that I get either heads or tails should be 1, or I am 100% certain that when I flip a coin, I will either get heads or tails. That makes sense. Alrighty, let's do question 2. I probably will get cut off for question 2, so make sure you watch the next video for it. But it says, when randomly picking from a deck of cards, what is the probability of choosing a card that is a heart or a king? Are they mutually exclusive? Explain why or why not. I do give you a visual here for the card questions, but I want to let you know that we are going to be talking about decks of cards a lot in this class now. And so if you go to the resource sheet where you have your dice, if you go up here where you have your resource sheet for the dice, I also included a resource sheet for a deck of cards. Whether you're familiar with a deck of cards or not, you should be able to use this resource sheet to help you. And there are 52 cards in a deck. And let's see now what's going on. First, we know that this is an OR problem. And since it's an OR problem, I need to ask myself, can these two things happen at the same time? Can I have a card that is a heart and a king at the same time? And you can look either here on this page, or you can look at your resource sheet. Can I have a card that is a heart and a king at the same time? Well, I'm going to go look at my kings, which I know are at the end here. And is one of them a king of hearts? Yes, right here. So they can happen at the same time. So these are not mutually exclusive. So are they mutually exclusive? No. No. They do happen at the same time. Happen at same time. Alrighty, so since they can't happen at the same time, there's overlap here. And so I'm going to want to use my formula for overlapping. And I'm going to stop this video and start another one. And that should be the last video, maybe one more, who knows.